Good afternoon, ma'am. My name is Ope Damilola Daniel, and this is the lab 2 for building a price prediction model using the 100 UK used car dataset. So, without further ado, we already have a prior knowledge of what the dataset contains. It contains car manufacturers like Audi, BMW, Ford, Hyundai, and a lot of other car companies. the the goal of this model is to kind of predict price, right? So I want to train a data model for that. So we import our data from this link, obviously zipped, so we unzip it and we basically get all we need to get from it. Then from that point on, we start reprocessing our data. We import all the libraries we need, and we now start to kind of clean the file a bit. Then we now specify, or basically kind of representing the data to different sizes. So the first obvious change I made from the work was changing the year from a continuous attribute to a categorical attribute. I wanted to see how the changes will impact the model. I did that for here as well as here. So I ran it. Then I did this to kind of build data pipe, and here to build the data loader with the batch size of 128. Then this is the representation of this is like the conceptual framework sort of the model we're trying to build. Then this is us building the model. Here we can see we import touch, we import neural network and all of that. Then this is a layer. I did not add any hidden layer, even though I experimented with it, but I did not add it in my final stuff. Activation function is real U. I left that unchanged. Then building a model, same as it was. So I now increase my embedding dimensions. I tested a lot of embedding dimensions. I tested from 2 all the way to 27 also, but I chose 24 because that was kind of the sweet spot. I didn't feel like it was overfitted, and I also changed my loss function to harbor loss from what it was before. I increased my learning rate to be that. I increased my learning rate, leaving the optimizer as Adam. Then the iterations, I set it to be 10 epochs per iteration. I increased the patience of the model. I now run it. Then at the end, I got this. So from this data, we can see that the training data is here. In as much as it's not as the slope we are used to, it's still apparent. Then the validation is under it, meaning that the data is not overfitted. And from it, from the scatter plot, you can clearly see that the model is quite accurate in getting the predicted price from the actual price. Then, as you can see, the R2 score is 94, which was higher than what we did. So what I want to do now, I want to quickly add other stuff to it. That will be first thing I want to add metrics. I've already made the scripts beforehand, so I will not make the video longer. I did this so I will not make the video longer. I'll just set it like this, so you can see I use an F string in Python and now concatenated everything. I do not want to code it in this video, so did this and this. So the R score, oh my god, I even made this mistake. The R2 score is that's 94. The MSE is that, and the MAE, mean absolute error is that. I do apologize for making this video as long as it was, but thank you. That is my observation from experimenting based on the lab 2 work. Thank you so much, ma.